I will always start off with a 0-parameter model, followed by a 1-parameter model, followed by a very simple linear model. And each of those should be an improvement. So the 0-parameter model, which I'll explain in a bit, should be the worst, followed by the 1-parameter model, which should be a little better, and then followed by the very simple linear model, which should be a little bit better than that. And that kind of establishes, that kind of pegs a few numbers so you can have a good idea of where this is going.
Hello, everyone. Welcome to the Data Scientist Show. Today, we have Max Sklar. Max is an engineering and innovation labs advisor at Foursquare after 7 years at the company as a machine learning engineer. Previously, he has worked on ad attribution, recommendation bots, ratings, etc. He's the host of Local Maximum podcast. Today, we'll talk about his career journey, project he has worked on from junior engineer to senior engineer. And if you like the show, subscribe to the channel, leave a comment, and give us a 5-star review. Welcome to the show, Max.
Hi, Dalian. Thank you so much for having me on the show. We've been trying to make this happen for a few months, and I'm glad we finally made it happen.
I know. I'm so excited to talk about your journey. So you studied computer science from Yale and holds a master's degree in information system from New York University. How did you get into machine learning?
Yeah. Oh man, I'm going to have to dive deep in the bowels of my memory now, because that's quite a long time ago. So let's see. Yes, I studied computer science at Yale. We can get into why that is. I think those decisions that I made at 20 years old were basically because, computer science was a lot more interdisciplinary. I was interested in mathematics. I was interested in physics and all that, but I wanted something that had a little bit more of you could talk a little bit about design. You could talk a little bit about psychology. You could talk a little bit about, there was more of a breadth of different parts of your brain that you use in computer science. That's kind of how I got into it initially. Machine learning. So first of all, I was always kind of intrigued, even when I was an undergrad, by this idea that writing code is really hard, really complicated. What if we just have the machines write our code for us? Essentially, we could extend our reach. That's the phrase I've been using. Extend the human reach of software. But it was really in grad school where I started to dive into it a little more. So let's see. After I graduated from college, I worked for 3 years in a bunch of jobs as a software engineer at some companies in New York. We could talk about those if you want. But then I wasn't too happy with those. So I ended up back in school, and I ended up at a program at NYU that was half computer science, half business school. And the reason why I did that one was basically, computer science master's was kind of like, well, what's the point? I've already had the software engineering job, and I already have but I did want to learn more. And then, so I took a little bit at the business school in that. But as I was studying computer science for the second time, I really started to get intrigued a lot more by the ideas in probability theory, and a lot more by the ideas specifically of Bayesian inference, and the idea that you can kind of encode your belief, and you could encode how those beliefs should change when you get more data. And so it was like, okay, great. This is sort of the computer equivalent, the computational equivalent, if you will, of the scientific method. So we could actually have machines kind of make sort of neutral decisions for us based on the data. And we could add our own opinions in there too, but at least we know what biases we're adding, and we're not doing it in some haphazard way. So that was really interesting. So when I was there, I took I started with a data mining course at the business school side, but the one that really took off for me was Jan LeCun's class on machine learning at NYU. And I'm sure a lot of your listeners will have heard that name before. He's currently, I think, like head of AI at Facebook. He's one of the old school researchers in AI. So I really enjoyed that class. And then I just kind of self-studied a lot. And I even self-studied, I continue to, but like even into my job, just trying to learn, different methods and different ways of doing things. I know that like, deep learning is the big hot thing right now. And it was, believe me, I heard about deep learning in 2010 when I took Jan LeCun's class. I mean, I'm interested in that, but I'm interested. I've really grown my interest in the kind of Bayesian inference approach, where it's like, okay, how could you build statistical models in a principled way, and just realizing the power of that over the years, and sort of kind of building up my expertise around that idea. Essentially, not that I haven't branched out to other ideas, but that's really a core one, and it's a core theme of the podcast as well.
Yeah. Thanks for sharing that. So you learned some Bayesian method in school, and have you used any of those methodology in your projects later?
Yes, it was taught in the classes, but it was like, for me, it was, this is such an intriguing idea. I want to learn more and more and more. So I kind of bounced out of that, and I put it to use. I put it to use at work. I put it to use at Foursquare. When I was building out the rating system there, I put it to use again at Foursquare when I was working on some of the ad measurement product. Basically, I kind of take that approach in any machine learning or data project that I build. Like, I sort of ask the typical questions that you would ask if you're doing Bayesian inference, like, what are my hypotheses? What are my priors here? What am I trying to learn? Sometimes just like, the best question to ask is the first question before you get into any equations and stuff. But like, what are my potential, what's my hypothesis space? What is the space of things that I'm trying to learn? I feel like even in when you're tackling personal questions, and if you have like a question in your life that seems intractable, just writing down all the possible answers and even the wrong answers sometimes is way more helpful than you'd think.
Yeah, thanks for sharing that. So Bayesian method is not just some statistical methods. We can also use it in our life to make decisions. So you mentioned a few projects at Foursquare, and let's start with the rating project you worked on.
Right.
So what kind of Bayesian method you have applied there?
So right. So that was just so that the audience knows how long ago this was. That was, we started this. We started working on this in like 2011 and put it out in 2012. So that's 10 years ago already. But it was very impactful. And in fact, we redid it a little in 2014. But if you go to the Foursquare City Guide today, every venue there is rated 1 to 10, and they're still using the same rating system that we built in the past, mostly because they've been in maintenance mode for a while. But the fact that it's held up, I'm pretty proud of that. There's a lot of components to ratings, so we don't have to go through all of them. But one of the trickiest parts that we found, but also the most helpful part, was trying to take all. So back in, for those of you who, you probably have a lot of listeners who used Foursquare back in 2011, 2012, 2013, and we're like, oh, Foursquare, that's still around, but it is. And it was very popular back then. And people used to add, you still can, people used to add little tips at places, which are like 2 or 3 sentences. I think the reason why it was originally called tips, because it would tell you like what to do there, but they also contained sentiment information, like, is this place good or not, or what's good to get, and so on and so forth. So the trick was to try to have the machine automatically figure out what the sentiment was on those tips, because the tips gave much better signal than the explicit likes or dislikes, which I think is true in a lot of cases. I think it's true, let's say you have a video app, for example, and you have likes and dislikes on the video. That might give you some indication of what's going on, but I feel like people are hitting that like button. People are smashing that like button a lot more than I don't know how meaningful it necessarily is. A lot of people are just clicking away, whereas writing some text actually means something. So I felt like we'd get a better signal out of that text, and we did. We used the explicit ratings as well to an extent, but it was really hard to get that sentiment analysis out of it, because it was a very specific type of text. I think some people tried things that were like pre-calculated, used for Twitter, maybe, or used for Yelp, which had long form reviews, and it never really quite worked. And so what I did was ultimately was say, look, people are leaving tips. They're leaving explicit ratings like likes and dislikes. Some people leave both. And there you go. That's an automatically labeled training set. And what's great is like our users are labeling it. There's millions of examples. There's examples in lots of different languages. I think we had like 97 models, although probably only like a dozen or so of those were any good, if languages that had enough data in it. But it worked very well to gather the data in that way. Now, in order to get that to work, so you asked how Bayesian inference is used. I can think of like two levels on which that's used. First, there's the general Bayesian inference when we built that sentiment model, which I could tell you is not a very deep NLP model, but it was somewhat sophisticated to get it to work because it's elastic net logistic regression on phrases in the tip from 1 to 4 words. So it actually did get quite a bit of context in there, even with 1 to 4 words. We didn't actually have to do natural language understanding or anything like that. There are probably tools you can do that today to do that. But I actually open sourced that type of logistic regression, which I did, which is it's a little unusual because a lot of the logistic regressions online, like the standard one in NumPy, I think is not really meant for sparse data. The standard one for PyMC3 is not really meant for sparse data.
Why is that?
I think, just typically people, when they're doing logistic regression, maybe the typical use case that it's used for in the wild is, I don't know, let's say you're trying to predict elections is a good example. Like, let's say you're trying to predict how people vote and based on their demographic information. Well, you might have like 30 or 40 different pieces of information on that person on demographic information. And so that is a dense model. You could just store 30 numbers. Whereas in this case, it was like, okay, there are gazillions of different phrases that could be in this tip. And for each one, it was a 1 or a 0. Does this phrase occur? Or maybe it was actually counted like the number of times this phrase occurs. And so that's sparse data. It's, most of there are many features, potentially infinite, although in practice it's cut down to a certain amount. And then most of them are 0, so you don't have to store them. And then, some of them appear. So yeah, I had a kind of an efficient implementation of that. I'm sure you could find more other ones online, but if you use the ones that's in my open source, which is on my GitHub, Max Sklar /BayesPy, BAYESPY. Anyone should ask me if you're curious to use it with me, because I can get it working pretty quickly. So there's Bayesian inference for that because you have to have priors around your feature weights. So that's one instance. And then another instance, which is very important, is like, what's our prior rating for a venue in Foursquare? Let's say we're trying to estimate the percentage of people who leave a tip that will leave a positive tip. So let me see if we can understand that correctly. We're not trying to predict the percentage of people who will leave a tip, which might be an interesting signal in and of itself. But of the people who leave a tip, how many people leave positive tips? Let's say that's the numerator, and the denominator is the number of people who leave positive tips plus the number of people who leave negative tips. So a certain percentage, right? And so you kind of ask, well, what is your prior on that? And oftentimes when you're trying to predict in Bayesian inference some number between 0 and 1, some probability, you're usually going to use something called a beta prior on that. Interestingly enough, we had 3 different categories. We had a like, a dislike, and a meh. And even though they're ordered, we consider them 3 different categories. So we had a 3-dimensional version, which is called a 3-dimensional Dirichlet prior on that. Let's talk about beta to make it more to make it less complicated. The beta prior can do a lot of interesting things. So in our case, it can sort of encode the idea that we're not going to make up our minds until we get a certain number of, yes, each piece of information updates the beta prior, but depending upon how strong the weights of the beta prior are, we could either make up our minds very quickly or take a long time to let the data speak for ourselves. And there was a certain amount of ratings before before we'd make up our minds. I think it was like 8 to 10, because there's a certain amount of every place has a certain amount of haters and likers kind of baked in, is what we found.
Yeah. Thanks for sharing that. So whenever it comes to a Bayesian problem, like you mentioned, it's very important to find that prior. And I assume in your use case, you have a lot of data. So even if the prior in the beginning wasn't super accurate, you're able to update that. But in some other cases, when data scientists feel they're not sure about how to pick a prior, how do they decide whether Bayesian method is good to solve those type of use cases?
Right. For each venue, we might not have that much data available. There were a bunch of other models we did like this, where it was like, we wanted to know which time of the day was a good time to visit. And we had priors on that. And the prior basically said, you're probably have a not even knowing what the place is. You're probably a better bet going at 4 p.m. than 4 a.m. I'm just guessing here, but that's the prior. The reason why we had to start thinking in terms of priors was because we didn't have a lot of data for each venue. And the reason why in like sparse models, especially sparse linear models, like logistic regression or linear regression, you need priors because, which is also, known as a regularization term when you're turning it into a machine learning, like a loss model, because you might not have a lot of data for each feature. And so it could overfit. It could essentially be like, okay, this feature appeared in my training set 3 times. Each of those 3 times we got a hit. Okay, this feature must be a 100% determinant. And of course, that's ridiculous. It could just be a luck of the draw. So
Yeah.
you need to think in terms of priors, especially even when you have a lot of data, because often when you have a lot of data, you have some features that are sparse. You have, in the case of like a rating system, whether it's products or videos or places, you might not have much per item. So I think Bayesian inference is always the way to go when you have that, because yes, you could start off with like kind of the poor man's version, which would be like, okay, I could just eyeball it. I won't make a determination until I get X number of ratings or whatever. But if you want to do that in a more principled way, you really should think of terms of Bayesian inference, like, okay, what's my prior? How is my data changing that prior? And at some point, my encoded belief looks good enough to display, essentially.
Yeah. And there's a lot of discussion online when it comes to Bayesian, frequency. Sometimes people position those two as one against another. So where do you stand in the spectrum?
I'm hard Bayesian, as you could tell, but I don't, I'm not really like allergic to frequentist type methods, so long, but it's just a little bit more confusing to me. My mind thinks in the Bayesian way. Now there are certain problems that you could come up with if you use frequentist methods. Like, one of the really frustrating ones is p-values, which we could suss out what that means, but oftentimes it's not very intuitive if you're explaining to the outside world. Like if you're explaining to the marketing department that, okay, my model says that there's a 60% chance that this is the case, they can grok that. But when we're understanding p-values, I think people misunderstand that a lot. And there's a lot of funny business that can kind of go on where you try to something called p-hacking, where you try to run the model many times until you get the answer you want, which, by the way, when measuring ads, oh my God, people wanted to do that because they wanted their ad to be measured a certain way. And, as someone on the data side, that got me very frustrated. It caused some friction there.
Yeah.
But I prefer the Bayesian methods. I will say it works for me better than anything else that comes along. Interestingly enough, I've come across another group of people while doing the podcast, and especially getting more into like philosophy and current events and stuff.
Yeah.
And that's like a group of people who like call themselves the rationalists, who sort of try to boil down all life to rationalism and the scientific method. And I don't go that far. I feel like there's some limit to what this can tell us. I think that there are certain assumptions that you have to make before going through the scientific method. I feel like there's a little bit of like self-referential there. Like, well, how do you know the scientific method is good using the scientific method? Well, you can't. So it was interesting to kind of come across that group, which, they have a lot of interesting things to say, but I haven't gone down that ideological rabbit hole. I don't think I fall into that category.
Yeah. I think that's a good segue to talk about the ad attribution project. But before we get into there, I think it's very interesting you talk about when it comes to p-value. Sometimes it's a little tricky, and I have similar experience.
Yeah.
I used to work with product owners, either product managers or engineers, and they're so invested in the project. They really want to launch it. So they will find different ways. They will try to parse the data into certain groups or looking at specific devices and find a metric that wasn't specified in their original experiment design and want to launch the experiment. So can you share more about some frustration you had there, and how did you try to convince people when you talk them out of launching a product?
It is. Well, actually, a lot of my frustration with the p-values was around the attribution product. But even before that, I mean, look, Foursquare was the type of company that would run A/B tests and would try to determine whether a change is good or not. When you have a consumer application like that, it's tough to be entirely data run. And one of the one of the things that I ran up against that maybe is human nature were people who claimed to want to make some changes because the data said, when really they are just cherry picking, what the data said to do what they want. Now, look, there's nothing wrong with saying, hey, I have a vision for this product and this is how I think it should be used. Or maybe we have a committee of engineers and designers, and they're like, hey, it would be cool if it works this way. We think it works this way. Maybe we'll test it to make sure that it doesn't like destroy our metrics or anything. Mm-hmm. But maybe we'll come up with an editorial opinion. I don't necessarily think that's a bad thing, but I do think that people should be honest about what they're doing. It does get kind of manipulative when you might have some like certain people in the organization who might be like, hey, the data says we need to make this change. That's a change I want to make. Maybe it's not, maybe we don't have consensus for it, but I'm kind of shoving it down everyone's throat because I have data, when it really is not as, it's not as cut and dry. So I would just encourage leadership on these products to set the tone. I mean, if you only want to do things that are data driven and you want to be like, hey, it has to be absolutely certain that it improves metric, that's one decision you could make. But I think your engineers and designers and everyone would thank you if you're just honest about how you make those decisions.
Yeah. I think a lot of times because of business metrics, and people want to find those evidence. But if you think about a business, if you think about like iPhone, probably no one run experimentation and say, oh, iPhone is a good idea. So data will not always tell you everything about business opportunities. Exactly like you mentioned, sometimes you can just be honest. Okay, I'm just going to make a bet, and then you can ask a data scientist to help you make an estimation. Okay, based on the statistical results, what is the potential risk? How much money I might lose? And if I'm okay with that, I'm just going to launch it and have some guardrail. It doesn't have to be a one-way door. If I lose a lot of money, I can quickly roll it back. But there's learning from the experimentation.
Yeah, the fact is, most changes, particularly to consumer apps, don't really show up in the metrics very often. But there are other reasons why you might want to make those changes. Like if you're rebranding, the rebrand itself might not make any changes, but you might be like, okay, look, this is how we want to present ourselves to the world. Or maybe, one of the big costs in software, both from the product side and from the engineering side, is if something is more complicated, it's much harder to maintain. It's much harder to explain to the user. So, okay, if you could make something less complicated, I don't know how you necessarily measure that, but if everyone kind of agrees doing it B versus A is less complicated, then even if it doesn't show up in the data, that's another reason to make a change.
Yeah. Thanks for sharing that.
Yeah.
So can you?
I probably didn't finish because I had to talk about p hacking in attribution, which I actually think is kind of common in the industry. Fortunately, I made sure we didn't do it, but that was basically you're measuring the effectiveness of ads, and that was something that was a shock to me because I'm like, well, the person who's running the ad, who's paying us to measure this ad, its effectiveness, they don't want us to p-hack. They want us to give them the correct assessment. So I assumed, but it turned out there's like a bunch of middlemen in this industry sometimes. And so it's like the people who are running it on behalf of someone else, wants to have their homework graded. And so they often don't like our results. And they're like, well, we'll go to someone else if it shows our ad didn't work. And, we found, look, there's a good percentage of ads, particularly in the location space, that just don't work. I don't remember exactly how many it was. If it was a few years ago, if I was closer to it, I remember something like 30% of ads just had no effect. I mean, that makes sense, right?
Yeah.
So there's sort of a tendency to, sometimes you need to run things a few different ways if you screw it up, if you want to add more features or whatever, and you could get quite different results. So sometimes it's a little dangerous. It's not entirely pure, but you kind of think at some point you're like, okay, now we're p-hacking, and you really have to push back if people who are not, not on the data side are interested in doing that.
Mm-hmm. Yeah, I think in the organization, probably from the leadership side, data-driven is important, but also make people feel safe to take some small risk, and even if it's not supported by data. So can you tell us more about the ad attribution project?
Okay, this was the system that Foursquare has. They still have an attribution product to this day. And what they do is a company like a chain, for example, maybe a Starbucks, maybe a Dunkin' Donuts, someone like that, or even could be a fancier chain, or could be like a chamber of commerce or something, will want to know if their ads are actually driving people to physical places. So a lot of ad measurement online is it getting me to click? Is it getting me to buy the product? In this case, the measurement is this causing people to go to physical places? And since Foursquare has that data, they can give that answer. The trick there, and the thing that's very difficult to do as a data person, is causality, especially in this kind of environment. Yeah. It's like, well, did these ads actually cause people to go there, or were those people going to go there anyway? Am I just shouting at someone as they're walking into the door to go to a place, and then collecting credit for getting them to go in there, even though they had, because you want to target those marginal people. That's really hard. Usually you're targeting people who have a propensity to go anyway, and you want them to go more. So it's really tricky to do those causal analyses correctly, particularly because there are confounding variables, which is like, okay, here's a variable that both affects who I'm targeting, and it affects their propensity to go, and it also affects how they're affected by the ad. So it's like it's hard to pull that apart, and it's like basically which variables do you want to control for? And so basically what you have to do is you just have to say, look, here's the information that we have. Here are the things that we can control for. And here's an argument why we think that there might not be any confounders, but you really can't prove that there aren't any other confounders. So, we can control for quite a few things. We control for age, whether they've been there before, demographics, gender, where they live, income, that kind of thing. Where they are, obviously, you're not going to go to a store if there's no version of that store within 100 miles of you. And hopefully you're not receiving the ad to begin with. But if there are fewer, you might not go either. So basically, we built a causality model along those things. Then we tried to get the average lift of an ad, which is like, what's the percentage boost in terms of likelihood that someone goes, like, let's say I had a 5% chance of going to Walmart today. Then I saw the ad. Now I have a 7% chance or something. So that's a 7/5 lift, whatever that is. Calculate that fraction.
So how did you build the causality model? Did you use a linear regression, or what are some other structures you used?
Right. So you usually use some kind of a linear model with lots of different features. There's a few different ways of doing it. The way we ultimately did it was we basically came up with a probability for each person per day. We would predict the probability that you would take the action that this particular ad campaign was looking for. So, it might be a few percent, whatever it is. And then we looked at all the person days during the window of the campaign, and we looked at who actually went, and then we used those values to come up with that lift. And there was a lot of complications that came up and a lot of different fuzzy things here and there that we had to clean up, but that's the gist of it. And then on top of it, I mean, I could talk about the bias correction work that I did that worked out pretty well. The paper that I published earlier this year, if you want.
Yeah, sure. Definitely want to get to that. You mentioned there's some fuzzy things you have to correct. Can you share what are some challenges you faced in that project, and how did you tackle that?
Yeah, well, there were definitely a few cases where the causality model was just broken. A few examples were places like theme parks or tourist ads, destination ads, because we were using as features the place that the person was at the time, at the day they visited. Like, hey, I'm in Salem, New Hampshire today. I woke up in Salem, New Hampshire here. So that's a feature. The problem is the ad caused you to travel. So that didn't really work. Like, yes, if you woke up in Orlando, Florida, now you're much more likely to go to Disney. But so that means that the ad gets less credit for you going to Disney because it's already counting on the fact, well, you have a propensity to go already because you're in Orlando, with ignoring the fact that the ad caused you to go to Orlando. So, or encourage you to go to Orlando, however you want to see it. So it's so there were a few cases like that where we had to have a mode where it was like tourist mode, where you had to back out and be like, okay, we're not going to use those features, and instead we're going to look at like where the person lived, for the 30 days before the campaign started or something. Another thing that broke one was there was one where like the lift was like negative 30%, which means that the ad was driving people away, and it was driving people away hard. And they were asking me like, what the heck is going on here? And I was like, no ad is that bad. It turned out to be an ad that it wasn't that the ad was bad. It was just a coupon for a haircut that people got for right after they got their haircut, and we were just measuring it for the next 2 weeks. And it's like, you don't need a haircut after you got a haircut for 2 weeks. So yeah, it's going to be very negative. So things like that would come up as well.
Yeah, those are great stories. I think when I worked in retail, sometimes if you run a promotion for something very expensive, like a refrigerator or furniture, maybe the customer are less likely to purchase something down the line. So sometimes just looking at the aggregated numbers in the experiments might not tell you the whole story. So you might want to look at specifically what are the item related, understand the journey of the customer.
Yeah, exactly.
Yeah. And also, I think it's very interesting you build a model to predict some propensity score for each individual, especially when you collect those data online. I think there are different life cycle of customers. So some customers, you have a lot of data and they're loyal. So those customers model might be more accurate, and they're like new customers, new sessions might be bots. So how do you make sure the customer data you collect are reliable? And do you have different models for different type of customers?
Right. Well, to be perfectly honest, in this particular case, the data was kind of cleaned in that way before it got to me.
Mm-hmm.
But I think this is location data, so it's a little bit different. Where we're looking at phones and devices that are going to specific places, and it's kind of hard to. You could certainly spoof that, but it's much less common
Okay.
than a bot you would get kind of in a purely digital environment. I
Mm-hmm.
think.
Okay. So not a lot of surprises
Yeah.
when it comes to.
No, but we did a lot of work over years and years to make
Mm-hmm.
to get the data up to that point. And I believe that Foursquare still has really good data to this day that does just that.
Yeah.
Even though I'm not there anymore. Yeah.
Mm-hmm.
I should mention the bias correction work that I did on
Sure.
that, because that's where that came out of. So I published a paper on Archive earlier this year in May called Sampling Bias Correction for
Mm-hmm.
Supervised Machine Learning. And it basically came out of the idea where when we were building this model, and it was like, okay, I want to predict the probability that you will visit, I don't know, Crumble Cookie on this Friday, upcoming today, Friday. So, okay, what's my training data for that? Well, all the users times all the days. And almost every single user day, they're not visiting Crumble Cookie. I'm just mentioning that because there's a Crumble Cookie out here. So it is a highly imbalanced data set, and it's a humongous data set, and it takes so much time to process. And so the question that we asked was, a lot of these negative days, people that didn't go, can we just throw the majority of that out? So like randomly sample just in that, because we don't want to sample out examples of people visiting, because those are very valuable. Those tells us what's really going on. Can't we just throw out a lot of the background, because we do need something to compare it to, so now they're roughly equal, and then train on that? And the answer is yes. You might lose some information, but because that data is so abundant, you're not losing a whole lot of information.
Mm-hmm.
You can do that, and there's a principled bias correction formula that you could come up with to run it through, and we did it, and it worked exceedingly well. Made our models much more efficient to run, and in the paper, what I do is I basically come up with a general solution of, if you have a supervised machine learning problem and you want to sample it down in some way, basically in any way you want to sample it, how can you learn a model that, so long as you know how you sampled it originally, how it was sampled, maybe someone else sampled it, how can you run your machine learning algorithm so it's actually trying to learn a model that fits the original data set? And so that's what that does. It's the general solution. I don't think it's actually been like, you could find a bunch of papers where it's like, here's the solution for logistic regression, which is what we did. But I don't think it's ever been put out in that way, that this is kind of the general solution for supervised
Yeah.
machine learning.
Thanks for sharing that. So I'm sure you have a lot of formulas in the paper. I encourage folks to check it out. But on a high level, can you give us some intuition how that formula works?
So essentially, what you're doing is you're starting with the concept of Bayesian inference, right? And now there's just one more step in that Bayesian inference. So it's like, hey, I'm usually in Bayesian inference, you're like, hey, I'm seeing this data, and what's the probability of seeing this data under this hypothesis versus under this hypothesis? You're still asking that question now, but now you're like, okay, under both of these hypotheses, the data has been filtered. And so now what's the probability of seeing what I'm seeing? So that's kind of the that's kind of the question that you ask, and then you work back from there. Interestingly enough, there really isn't any change if you're filtering on the dependent variable, on the features. The only thing that changes if you filter on the features is your model. Like, let's say it's a logistic regression model, and let's say you, for some reason, you want to remove all of the items that have a particular feature in it. I don't know why you want to do that, but let's say you did that. The only difference is that that your model is now not going to learn the score for that feature very well. It's going to learn scores for other features. It's going to kind of rely on the prior there. So it will be a worse model, but it won't be bias in that it's over predicting or under predicting. It's just kind of, there's no change you have to make. In other words, it's just going to be fuzzier. But it's when you're filtering specifically on the label, that's when you have to change things, which makes sense. Look, if you filter out, the example that I give in the paper is, if you're trying to do an algorithm that image recognition algorithm where you're trying to figure out which pictures are of lions, if you train on half lions and half non-lions, it's going to think, wow, lions are really common. And that could cause a bias. It could cause it to over-predict lions. Now, maybe not, that's not guaranteed, but it could. So that's when you really want to make a change. And the key statistic there, particularly in the binary case, is like, okay, what's the sample rate if for non-lions divided by the sample rate for lions, or vice versa? It's kind of the ratio of that really matters, that kind of makes its way into the equation. Mm-hmm. So hopefully that makes a little bit of sense. And then, of course, when you have more classes, and then particularly when you're doing regression, it gets very complicated, but it's all based on the ratio, the sampling ratio of how would I have sampled it if it looked like this versus how would I have sampled it if it looked like that. And that could change, by the way, depending on what the features are, if you have some very complicated sampling function. But usually it's like, hey, I'm like in the case I was doing for causality on visiting a place. It's simple, it's binary, and it's like, hey, my sampling rate for the hits for the rare event is 0%, and my sampling rate for the non-events is some high number. So there's a constant ratio there.
Mm-hmm. Yeah, that makes sense. I think one challenge about causal inference is sometimes it's hard to test whether your inference is true. And specifically in this bias correction use case, how do you know after sampling the machine learning model prediction on the larger population will work? What type of testing, monitoring procedure you set up?
So the only way we really knew was to have, the models kind of spoke for itself in some ways. And when they started to make a lot of sense based on what was already known in the industry, that helped a lot too. I mean, I think people were a little disappointed at first because they were getting smaller numbers than they expected, but that kind of makes sense.
What do you mean by smaller numbers?
Like, okay, they were getting 5% lifts instead of 10% lifts, because we were taking into account the fact that, people were going to go there anyway. But we were kind of satisfied that we were getting a stronger signal. And I think there was a certain repeatability of this where like companies would do the campaign again and again and get similar results. And, it would sort of align with the data they were getting elsewhere. But look, I mean, with something like this, there's no guarantee. I'm sure that it's not 100%. There's certain cases where it's probably off because, again, there's so many confounders.
Mm-hmm. Yeah. And so how do you monitor whether there's a drift in the data, whether there's a behavior change? So we think, those ads are lived or attributed to this ads, and maybe after a while for certain type of media or device, you don't see that much lift anymore. And there might not be anything wrong in your model. There might not be any bias. It could be just people's behavior changed. So how do you detect that? Yeah.
So I mean, the way we did that was just the model was run differently every single time. It's not like we built one model, and then use that same model throughout. We were still using the same model 6 months later because we were actually modeling each day as a new day. That helped quite a bit. Yes, if you had kind of a propensity model over time, which is what they used to do in kind of one of the old versions where it's like, hey, run the ad for a month and don't run the ad for a month.
Hmm.
very bad. Things could happen. I mean, first of all, if there's a holiday, everything gets thrown off. So you really have to compare people on that day to other people on that day. And,
Hmm.
you just have to keep them as equal as possible. Sometimes it's not possible. There was one ad where it was like everyone saw it. So how do you measure how effective an ad is if
Yeah.
everyone saw the ad? It was like, it was one of those ads for, like a new Samsung phone. Like literally
Mm.
everyone saw the ad. Everyone in the world saw the ad. So you don't know how I think it was that it could have been an iPhone, could have been something, whatever it was. It was something like that where it was like, okay, if there's no one who didn't see the ad, you can't measure how effective it was, even though I'm sure those companies have a pretty good idea.
Yeah, I bet they can compare to some historical data,
Yeah,
have a, I don't know,
yeah.
longitudinal type of study. Yeah.
But they'll never know if it drifted. I mean, these are all
Yeah.
one off. Every single one of
Hmm.
these really are one offs. They're like, they're like presidential elections. You can't really predict that well based on the past. You might have a few good ideas, but ads, consumer preferences change so much over time that it's a lot like shooting in the dark, which is why I think these businesses that give some numerical feedback is very valuable.
Yeah. So throughout your experiences working on ads, what are some other unexpected results you have observed?
One of the interesting things was just how wide of a variety of answers that we got, whether it was 30% lift or 0% to even slightly negative percent lift. The negative lift problem was very difficult as well because um, nobody believes that your ad drives people away, and I
Yeah.
kind of agree. I think part of it was that the model is like, you know a lot of ads are neutral, and so sometimes just by pure luck, half of those will be a little negative, half of those will come out a
Hmm.
little positive. Hopefully there's a little bit of a Bayesian uncertainty curve around that, but those were very difficult to kind of explain to clients and things like that. So you might end up with a small negative value. And I was actually surprised that a lot of ads really worked,
Oh,
but
for
to the extent
example?
they did. Well, no, I don't remember the exact. I
Oh,
don't remember
okay.
the specific example. I'm sorry, it was a few years ago, but like, you know, you'd see ad campaigns that were like 15-20% lift, and it's like,
Hmm.
wow, they really got a lot of people to try their product, presumably. So, yeah.
Yeah. Has there been any cases when the lift is so high and then you're wondering, oh, is it too good to be true? And then you do a deep dive and realize there are some data issues?
Yeah, yeah. I mean, a lot of times there are ads that conflict with other ads.
Mm.
Now, fortunately, you know, there are some obvious things like, again, Black Friday or something like that, where everyone's going out shopping. That we didn't run into that problem because we modeled each day separately. So there really weren't a lot of problems like that. There were questions of, hey, there are multiple ad campaigns going on for almost the same product or same company or similar
Yeah.
product. How are they interacting with each other? And how should a, a company that has multiple ads and they're getting these measurements all at the same time, how much should they attribute to, like, hey, this is caused by ad one versus this is caused by ad two? Could it be the case that this person wouldn't have gone unless they saw both of those ads?
Yeah.
And is it necessarily like, oh, if this ad has a 10% lift and this ad has a 10% lift, do I then multiply 1.1 times 1.1 to get the new lift of
Right.
like 1.21? And the
Hmm.
answer is usually no. They interact in a very different way. It could be they have synergies and it's higher than that. It could be they have saturation and it's lower than that. And then if you want to pay the ad company by this amount, how much do you attribute it? If both ads were required to get these people to go? So many interesting questions. One mathematical theory or concept that I came upon while doing this work, and it's actually highly applicable to a lot of things in negotiations as well, is the idea of a Shapley value, which is like something where you look at what happens under, it, you know, you want to find out, well, what is the cause of this action? But you have several different actions taking place. And like all of these actions could cause this one event. And, you know, essentially you look at all the subsets of these actions, so like 2 to the n, and you say, okay, what's the effect of all of these subsets on the event? And then you
Yeah.
could kind of suss that out to get what is the power, how do I score each of these original actions? So it's actually highly applicable in negotiations. It's highly applicable in something like election systems,
Hmm.
where you can, if you have sort of a certain election scheme going on, whether it's the Electoral College or the or the UN or something like that, you can assign a score to each voter depending upon which subset of voters allow them to pass the thing, and it's useful in terms of attributing ads to actions. So it's a highly useful concept, and for people who are interested, I encourage you to have a look at that.
Cool. And what are some like other resources like books or papers people can learn more about this?
Yeah. So for causality, I like the work of Judea Pearl. I read this
Hmm.
book, the Book of
Book
Why.
why?
Yeah, I haven't gotten to like, I wish I had gotten a chance to actually use his system in the wild as directly as I would have liked to. But oftentimes reading that kind of confirmed that we were on the right track to what we were
Hmm.
doing. I did an episode early on with episode 31 with Shirin Mojara on the problem of causality. She was
Hmm.
applying it to educational test scores. So and she had a paper on that was pretty good.
Oh, cool. Thanks for sharing that. And when you work with consumer data, what are some interesting things you learned about human behaviors?
Essentially almost everything is a confounder. That's one thing that I learned. There are very few
Yeah.
things that have no effect, but except for ads. But there's a really interesting one I found early on when trying to do the ratings, which was that different languages, because we had to kind of look at different languages separately, had a very different rate of people who would leave positive and negative reviews, where the negative reviews in like in Japanese at the time, it was like 97% positive. Foursquare is very positive, whereas in Russian it was only 85% positive. Very different cases, and we almost felt like we should correct for that because you know there's certain cultures that are way more likely to give a negative review than others. So that was kind of an interesting data byproduct of that.
So, how did you grow from a junior engineer to senior engineer?
I don't know. It kind of just happened. I kind of just kept hammering on what I was doing over time. I think one of, there were a few turning points for me on that journey. I mean, one was in 2016 where the founder of the company, Dennis Crowley, wanted to build an experimental app called MarsBot, a chatbot based off of based off the technology that we had built thus far. And for some reason, a lot of engineers didn't want to do it because it was kind of outside the engineering org, and it was a little bit not standard for your career. And I volunteered for that, and that was one of the things that has really changed the way I look at consumer products. And then I think the other one was in 2017 where I was working on attribution, because the way I started working on that was not usually the company kind of says, oh, we're restructuring, this is where we want everyone to go. But I was actually talking to those team members over lunch and asking them about what problems they were facing. And then at some point I realized, hey, the stuff that I've been studying on the consumer side is very, like the Bayesian inference stuff is very applicable to the stuff that you're working on. So let's make this happen. And I think we've lost that now. Now that everyone's working from home, that doesn't really happen anymore. And so, that's an example of that bringing like lots of value to the
Hmm.
company that doesn't happen because we're all working from home. And I know I wasn't happy going in 5 days a week either, but I feel like the current work from home situation is not very amenable to collaboration. There's certainly a lot of loss there, but so that's the second one. Then I think rejoining the labs team in 2019 when I was working directly on that for the next version of MarsBot. I don't know. These are all just interesting experiences that most engineers don't get to go through. So I wouldn't say in terms of like my career, I've never been good at engineering ladders, so I stopped caring about them. I just
what do you mean by you're not good at with engineering ladders?
Yeah, I mean, like I feel like engineering managers in the engineering org always have a very specific engineering ladder set up about how this is how you move up the ladder, and it never really appealed to me, and I always felt like I had to twist arms to get to that next level. So I stopped playing the game. I was like, you know what? I'm just going to be, I'm just going to, study how to do the best job on these things and try to just keep hammering away at them until I'm smarter at them than anyone could possibly be. So, and then work from there. So I don't know. That said, I don't have a lot of career advice on that side.
Yeah. No, I think that's pretty good advice. Like, what you don't want to do, what you're passionate about. You just do more of what you're good at and keep learning. Sounds like you created some open source project based on your passion. And I don't think we have to outfitting the career ladder. Someone else has set it for us and we can build our own career or whatever you call it. I think at a certain point when you're so interested in the things you do, it becomes part of your life. It's not just like a career anymore.
Yeah. And then actually now I'm looking for my next step, which I have been doing. But COVID really knocked me out. I really got a lot of energy from going in and collaborating on creative things with people, particularly in that last step when I was working on MarsBot with Dennis Crowley and Anish and that whole team. So now I've been kind of working at home in my own lab, and I've been coming up with some things, but I'm kind of hungry for collaborators. So we'll figure out where that goes.
Yeah. So I would love to talk more about your current project, open source. But before we go there, I want to see what are some other interesting or challenging problems you worked at Foursquare you want to share with us?
Yeah, I think that the other example is the whole MarsBot phenomenon, which, it was a challenge in terms of product and in terms of making it happen within the confines of the organization. Because it was a case of, hey, we're going to use all the models we built. Original MarsBot was like, hey, it'll text you. It still exists. You could download it, by the way. It'll text you if you go into a cafe. It'll immediately text you what to order there, which I think is an amazing user experience. And it's based on like all the math and stuff that we did beforehand and like ranking by sentiment, all the different noun phrases and items and the ones that make sense to display. And it's helped me out quite a bit. But in that case, it was more of, hey, I'm familiar with the models we already built. And we also have to kind of work through, okay, we want it to be SMS. We want a really good user experience. So it was kind of like it wasn't just a data science or machine learning problem. It was working through the full stack of product design and product management. And also, frankly, like, management of the executive teams. You have the support that you need. And that's one thing that, I want to focus on in the future is, look at like making sure that if you have a project asking like, okay, am I going to have the support that I need to complete this project? It's a hard question to ask, I think. In a lot of cases, a lot of places want you to do a project on the cheap. Sometimes you could do it. Sometimes it's hard to estimate how long a project would take, let alone knowing whether you have the institutional support for a project. So it's like, and sometimes you have to twist some arms to get a project that needs to be done. Sometimes it's not worth it. Those are very hard questions for me to answer. And it's something that everyone, I'm sure I'm not the only one who wants to be better at that.
Yeah. And sometimes you have the support of your current manager, but sometimes your director quit or
Oh,
some reorg happened. Those things happen all the time.
oh my God! I had a year where I went where they had like 5 managers, and quite frankly, by the end, I was sort of like ignoring what they have to say, and it was like, I'm no offense, but you're going to be gone in like a month or two.
How do you navigate through that year?
So I basically just, I mean, I shouldn't say, but I kind of just ignored them. I mean,
Yeah.
I hate to, not ignored completely, but like it was more like, um,
Focus on the
the,
project at hand.
yeah, like I'm going to try to think, okay, what's going to be here permanently? I'm going to have to live with these decisions in a year or so.
Mm.
So what should I do? So there was some tension there. There was a lot of pushback where, a new manager will come in and they're like, we want to do things this way, this way, this way. And you want to believe that the organization is supporting them and making that happen. But when you happen to know that that's not the case, it's like, well, what do you want me to do? I hope I'm not in that situation again, to be honest.
Yeah. And I know a lot of people, when those things happen, they move to a different org or different company. What made you
Sure.
decide to stay in the same team?
Oh, that year at Foursquare, it was more like, I think that was the year I was working on MarsBot, and I was kind
Mm-hmm.
of working with the former founder a lot.
Yeah.
So I kind of was just working with him,
Mm-hmm.
and it sort of got me through it a little bit. I didn't. I sort of felt like I had two different teams, so
Yeah.
I kind of just stuck around. But I don't know. It wasn't. In retrospect, it was kind of like, like I don't know what the right way was to play that chaos. I might
Mm.
have done it the right way. I think that was also the time when Foursquare itself was moving from a consumer-based company um, to an enterprise-based company. And so that's
Yeah.
why you had a lot of turnover at the time. And I
Mm-hmm.
think a lot of people I'm talking to, including the managers I had there, who I'm not like criticizing, would agree, like, hey, it was a confusing time. So what do you want to do? I was kind of like, hey, I'm invested in this company. I kind of want to see how things turn out. So I
Mm-hmm.
stuck around.
Yeah. Yeah. Thanks for sharing that. And later on, you worked on product design. When you think about the entire product you built, not just the machine learning data science element. So what was the shift like? What are some new skills you have to learn? What are something you feel you have to change in terms of mindset or process problem solving?
One of the skills I feel like I should learn is, you know, being a lot better at picking up third party software and just using what already exists. I love to build my own models. And not only that, but I feel like I've been pretty good at it. And
Mm,
oftentimes when I use pre-existing packages, I find bugs in there. I find behaviors that I'm not sure why it's exhibiting this behavior, and it's very
yeah.
hard to figure out why. Whereas if it's something we built in house, we have, and yet it seems like the industry standard is not to go in house. Now that's not true for some of the very simple things like in Python, like numpy and sklearn and things like that, where you could get a good model going
Hmm.
pretty fast. I haven't gotten to, I mean, like in sklearn, like I've used gradient boosted trees, very
Yeah.
powerful model. And it seems like some of these deep learning models are the real latest and greatest. And I have a very good theoretical understanding of how they work, but I haven't really come across a project where I had to recommend that we go with that, because it was always the case where these other standard methods already work for your use case. So it's almost like, wow, I want to use this really cool stuff, but it almost seems like it's not what I recommend. And also I kind of enjoy building my own, so I almost would prefer to recommend that if I could. So it's sort of a hard situation for me, where a lot of ML engineers feel like having a lot of these deep learning projects on their resumes is the way it's at, and I've played around with them. I've used them. I've used, going way back to Jan LeCun's convolutional net. I've played with PyTorch and TensorFlow, but I haven't actually found a real world product where like, hey, this is what we should use, which is, interesting, I guess.
Mm-hmm. Yeah. And what are some specific product design elements that you feel a lot of machine learning engineers should learn?
So the one that comes to mind for me, a technique that I have used that helps for me to get organized is, okay, once you've figured out what you're going to learn and what your model space is, and you've got your model space and you figured out your loss function, this is what I'm trying to optimize here. I will always start off with a 0 parameter model followed by a 1 parameter model, followed by a very simple linear model. And each of those should be an improvement. So the 0 parameter model, which I'll explain in a bit, should be the worst, followed by the 1 parameter model, which should be a little better, and then followed by the very simple linear model, which should be a little bit better than that. And that kind of pegs a few numbers so you can, be a little bit, have a good idea of where this is going, like how fast this improve, how good do I think I can get this, and it's also very good in terms of bug checking, in sort of being a good smoke test from doing this properly. So let's say you're doing a binary classification. The 0 parameter model would be to predict for every element 50-50, percent chance. The 1 parameter model has 1 parameter, which is the probability distribution, the binary distribution. So for that one, okay, I'm not guessing 50-50, but let's suppose it's 5% of them have the positive result. Okay, so I guess 595 for each one, 0.05, 0.95 for each one. And then some very simple, let's say a logistic regression with a few features to get it better than that. So your loss function should improve at each step. And I feel like that establishes, you'll find a lot of bugs there if you have bugs in it, and that will establish a good baseline. Establishing baselines is really important to getting started, I think.
Yeah, I think that's a very important. If you don't know your baseline after you build a model, you don't know how much of increase, what is the impact you made. And especially, right. I think it's important to have this 0% model, right? In some use cases, maybe you just look at some statistics, mean or medium, to have a right. general estimation, to have that's some common sense. Yeah.
Yeah.
That's a 1 parameter. What are some common mistakes you see machine learning engineer makes when you work with them?
I think the one that I have to get to is, and this is very common advice, I guess, but it's to make sure that you're solving the right problem. And not only in terms of data and machine learning, but to ask the why behind it. In other words, what decision am I trying to make at the end of this thing? And so that kind of communication line between you and the product owner, the product manager, the end consumer, it's kind of important to understand that almost before getting started. I think that's the advice I would give there.
Yeah, and then you also talked about using more like third-party software. So can you share what is your tech stack look like? What are some software or what are some like library packages you currently use?
Right. So currently is kind of let's just go with it. Foursquare, basically, sure. Sort of a simple, bread and butter Python stuff, which might not be that exciting to people here, but the NumPys and the sklearn. In Scala, because we had a lot of code in Scala at Foursquare, particularly some of the data pipeline code. Mm-hmm. I used a numerical library called Breeze, which had the Metropolis Hastings algorithm, so we could run MCMC on some data, essentially search the space of solutions really mm-hmm. efficiently. I kind of like those more standard libraries, but what I can use is I can I understand a lot of the probability theories. So I get to use things like the log gamma function and the psi function and things like that, where that, you wouldn't use if you were just using some of the out of the box solutions, because a lot of it involved really trying to build a probabilistic model.
Yeah. I think a lot of machine learning engineers, including data scientists now, come from engineering degree, and maybe not everyone like you did learn a lot of probability theory, Bayesian method. So do you think that's necessary for people to pick it up later on in their career?
I think it's important, to know Bayes' rule and to know Bayesian approach and the Bayesian method. You certainly don't have to specialize it in as much as I've done.
Yeah.
So yeah, I would say that it's not, if that's not your thing, it's not, it's totally fine.
Yeah.
I do think it's some of the math stuff has allowed me to write things that I otherwise normally wouldn't write. Like one example is the Dirichlet distribution tool. And so that's the tool where it's like, okay, I have a bunch of multinomial data. A good example is venues. For each venue, I have a count of likes, a count of dislikes, a count of mes. I want to find the prior, now. And it's like, well, how do you, we talked about priors. It's like, how do you find the prior to begin with? Well, you have all this data. You could use the data to find the prior. And that's what I did. And Bayes Pi has that Dirichlet distribution calculator in it. I have another paper on that from 2014. And so coming up with an efficient solution to that was pretty cool, because you could like run this data through that system and it comes out with an answer pretty fast.
Yeah. And if you were to learn machine learning again, what would you learn?
I don't think I'd change a thing. I think I learned what was interesting to me. I would point out this as advice, now that I think about it. There are definitely things that you learn that are not as interesting as the time you learn it. And then you pick it up later when you're working on a particular problem and you're like, oh, actually, this is really interesting. So one thing that I've learned is that working on real world problems can spur excitement and enthusiasm for general methods.
Yeah. I wish I have read or did more real problems while I was in grad school learning probability theory or statistics. It was really boring for me and it was really challenging. I just can't wait to, do my exam and finish school so I can work in the industry. And now looking back, I really wish I could spend more time with a professor, ask more problem to really understand those theories.
Yeah. I mean, there's always it's always like you don't really know the right questions to ask until you actually dive in and have to solve one of these real world problems where it's useful. I mean, sometimes theory is I enjoy studying theory. So, and I'm sure a lot of people out there do too. But even then, like, you don't necessarily know the right questions to ask, even if you find it interesting.
Yeah. So what are you working on now?
So now I'm after 16 years of hard work. I'm taking a little break from official employment, but I have kind of an unofficial self-employment where I kind of have my own lab, Local Maximum Lab. I still do the podcast, Local Maximum. I've published some papers, and I'm building a programming language, which newmap.ai, which is teaching me a lot. That'll be a while before it's quite ready. But my take was, let's try to build something that from scratch that I think would be the language that I would have wanted to use had I started. I'm finding that it's incredibly hard to build a new programming language just as one person. But I'm also learning a lot about computer science and data science, and it's kind of making me rethink the sort of basic underpinnings for how I understand how data and programming languages work. So I'm also, going to try to publish more papers. And when I say publish, I mean, I'm not putting them I'll probably just I'm putting them in archive.
Yeah.
But hey, I'm open to ideas. I'm publishing some more mathy papers, but they're not like math PhD papers, but they're more like, hey, I'm taking some abstract mathematics, making it more compatible with computer science and applied probability.
Hmm.
I think they'd be interesting for machine learning engineers and data scientists to read, particularly the one that's out now, which is the bias correction one. So it's almost like, well, where should I put those? I put those on archive. I put those on my site. I sent them out to my email list. But if you have any ideas, or if any listeners have any ideas, please let me know. The one that I'm working on these weeks is really interesting. It's on the idea of a relative probability distribution, where you only care about the probability of one event relative to another. And the idea that I had is that if one outcome goes to 100% and the other probabilities go to 0, you don't want to lose that information of what they are relative to each other in case you want to make some decision based off of that. And you want to kind of know, you want to kind of take the limit of a system. And sometimes, even if it doesn't make sense from a Bayesian perspective, you never want to put one thing at 100% and everything else is 0%. You always want to make everything kind of possible, but you want to be able to model the impossible case because you want to know what is the outcome of the extreme conditions of your system.
Hmm.
So that's kind of what I wanted to write about. And I wanted to harken back to abstract probability theory to make this all work, and maybe write some code that does it as well. So I'm looking forward to getting that out.
Yeah, thanks for sharing that. So you're designing a new programming language. What are some problems you're trying to solve? What are your biggest frustration with the current programming languages?
Right. So, I mean, I was showing this to a friend the other day, and I was like, I think my problem is I'm trying to solve every problem in computer science, and that's why it's going so slow. So a few of them are, first of all, the versioning problem of both data and code. So
Mm-hmm.
if data is code and code is data, how do you version that? Like if I change a schema, but there's an automatic conversion between the old version and the new version, how do I account for that? And then secondly, like how can I encourage more like algebraic data types in the data science world? Oftentimes we're just using structs with fields and they're all doubles, and that's kind of boring. I mean, yes, with R of Rn Euclidean space, you could kind of model a lot, but what if you could model lots of different things? And also, like, what if the machine knew, like, hey, this is a word, but it's also the name of a city, so maybe I could connect this with other databases. So those are the kind of things I'm thinking about. And if you could say, well, that sounds like it's all over the place. Yeah, you're right. That's why it's really hard to do. I need a product manager.
And have you used Bayesian methods for your life decisions?
Oh, absolutely. Absolutely. A good example, I don't know if I want to, no, why not? It's not exactly, I used to have these canker sores in my mouth that were really, really painful, and they had them for decades. Right.
Yeah.
And so at some point I was like, this is untenable. It's ruining my life. What can I do? I basically, all these doctors and stuff said, had all these responses, but none of them seemed to work. None of them really seemed to take it seriously, even though it was like a big deal for me. So finally I was like, look, it's been going on for decades. If this takes years and years, I want to fix this. So my first thing was, okay, let's actually use Bayesian inference. And I knew to gather enough data, it would take 6 months to do anything. But I'm like, okay, we'll just go one by one. We'll start now. And, what data should I collect? So that was an example where I solved it almost on the first step. I was like, okay, first step in the Bayesian inference problem is come up with all your hypotheses. So, okay, so I looked at what all the doctors said and I talked to as many people as possible. And a friend of mine was like, he's not a doctor or anything. It was like, it almost sounded like conspiracy theory. I didn't believe it. He's like, oh, your toothpaste is poisoning you. It's SLS in your toothpaste. And I'm like, all right, sure. So I put that on my list of things. People are like spicy foods, don't eat bread, take medication, all this stuff. I listed out every possible thing that could fix it, or to add or take away from my life, or get more tests. And then I decided to put probabilities on those in terms of what was the probability they could fix it. I had a hard time distinguishing between those, but then I decided, okay, what has the least cost to implement? And I was like, well, change your toothpaste. That has the least cost to implement. So I was like expecting like, okay, if there's a change here, it might be like, it might affect the problem by 20%. I might have to go a year to figure out if that was true. It turned out I changed my toothpaste and it was all fixed. It never happened again.
Oh, wow.
I was like, yeah, I was like, oh my God. So I didn't even need to do the data analysis. This was just like, this was the first step of Bayesian inference that you wouldn't even, because I had all those in my head, you wouldn't even expect fix the problem, and that fixed the problem. So that was a big one, surprising. That was a huge benefit to my life.
Thanks for sharing the story.
And
also, I think a lot of times the most important question, like you mentioned, is to ask what type of data should I collect? And you can argue like, oh, data, we talk about the data, we try to make it unbiased, but this question itself is highly biased based on the person who is thinking about the problem, collecting the data. So when we think about what data we should collect, what data should we use? Do we need more data? So we need to think about this as something that might later on really has an impact on our model, on our product.
Yeah, for sure. It's what data you collect. What are your hypotheses? So first is what's the question, then gather hypotheses. Then you have to ask, well, then there's the third question. What data do I collect? Because that comes at a cost. Again, it goes back to the bias correction thing. You've already collected the data, but processing the data comes at a cost. So what do I want to use? And the fact is, some data is much more valuable than other data. And so that's a question that is, I feel like there isn't a good, we answer that based on intuition now. There isn't like a good theory on that. I feel like there could be. Maybe that's something that somebody could come up with.
Yeah. And I worked with a manager, and he told me, when you think about what data you want to collect, don't get limited by the data set that are just available. Just imagine you can have all the resources, and then think about, okay, if I can have all the data in the world, what data would I like? And then you think about, okay, what's available? What's something I need to build to collect? And even that's really hard. Maybe you can find some proxies, but at least doing that type of exercise can help you, expand and limit yourself.
Yeah. One of the most surprising things, and I get into this trap all the time, where like, I don't need to write it down and do the exercise. I have it in my head, is how beneficial that could be sometimes.
Yeah. Because sometimes I think the things in our head could be like images or just a few words. It's not really processed in a logical way. And I think that's, I worked at Amazon for 7 years. So I think that really help me form a habit. Like if I want to have some personal project, I would try to write it down. And then I realized, oh, wow, that's actually is completely different from what I thought I knew in my head. So, yeah.
And that's, I think it's the same thing with writing too. If you're going to write papers or technical writing or any kind of writing, whether you're writing articles or op-eds, the act of writing down your thoughts is forces you to refine your thoughts.
Cool. So do you have a mentor?
Do I have a mentor? Well, I would say kind of on the product visionary side, Dennis Crowley at Foursquare, the founder there, was my mentor, who I worked on a labs project with. He obviously was not on the machine learning side, but I kind of learned a lot from that about having a vision for a product and pushing forward. I'm having trouble kind of coming up with an answer on the data science side, believe it or not. I just kind of go my own way. I had a few really close collaborators at Foursquare who I bounced ideas off of very well. I mean, can name them, but there were a few, so I don't want to leave anyone out.
Cool. So, what are some mistakes you made in your career?
I mean, I'm still not certain, like, what the goal is in the career trajectory.
Mm-hmm.
Like, I wouldn't say it's a mistake, but I often get very confused over, like, well, what should I be doing? And I think I had a lot of stress about that early on, that maybe I needed to go through that, but I don't know, maybe not.
Mm-hmm. What type of stress do you feel you have, like something you feel uncertain?
I'm just kind of, should I be an individual contributor
Mm,
for this long? I mean, I have something that I'm good at, but I don't know if this is what I should do forever, kind of a thing. So it's sort of like
mm,
it's sort of like a test on that. I think someone looking at my career trajectory from afar, might be like, hey, you know, why did you spend this time on these labs products and not on machine learning? And it's like, yeah, well, I think it goes back to, again, how we started the interview, where, I chose to go into computer science because it was more interdisciplinary. I like working across a lot of different areas of human life and human activity at different
yeah.
parts of my brain. I really have a hard time figuring out what I'm going to do next at this point,
Mm-hmm.
because it's always like, well, you don't necessarily want to do what you've done in the past
Yeah.
over and over, and yet that's what everyone wants to hire you to do, because that's what you're very productive at. So
Yeah.
it's a very hard problem.
Yeah, I have the same challenge. I think after I got promoted to a senior data scientist, I was thinking, okay, should I become a principal data scientist? Should I be a manager? I tried being a manager of a one-person team for a few months and realized I don't quite enjoy that. It's different from what I thought it was. You don't just lead projects, you also have to do a lot of HR stuff and just a lot of
Yeah.
meetings. And I think now I feel like I'm individual contributor. I can do my podcast. I have a newsletter. I can do YouTube. Maybe I can do
Yeah.
TikTok.
So
It's
we went a
exciting.
similar route, where it's like, yeah,
Yeah.
I don't want to be anonymous behind a computer my whole life. I didn't want
Right.
to do that. So I was like, yes, I want to get out there. I want to be I want to be a leader in the industry, and on other things as well. I mean, my podcast goes into all sorts of places. I want to get out there more, which is why I'm really happy to do this podcast today. It's actually been quite a few months, maybe even a year, before I've done other people's podcasts, and I would like to do them more often.
Yeah, it's really fun. And maybe we can also do some Bayesian experiment to see what is the next best action for our career. Yeah. So yeah, you talk about something you currently working on, but in the short term, the next say 3 to 6 months, what are something you're excited about in your career or in your life?
Well, I'm kind of looking forward to this next step. I'm looking forward to doing something new. First of all, like this year, I'm really looking forward to the resolution of some of this research, some of this kind of independent research that I've been doing, and to get these papers out, to get that feedback, and to talk about some of this abstract math stuff that I haven't gotten to express in the past. I'm kind of curious as to how it will be received, as it straddles something where I'm always kind of worried, like, well, the PhD mathematicians will kind of think, well, this is not really novel math, but it's, and then the data scientists will think, well, this is too mathy for me. I'm kind of curious to see if I could find people who appreciate this middle ground here. But to put some of these ideas that I've been thinking about for years and years on paper, I'm really excited about. And I feel like some really cool things are going to come out of it. And then to find out what my next, what my next adventure is. So into 2023, which I'm not quite sure about now. I have not been in a rush. I'll tell you that. So I'm not in the position where I just want to take anything that comes along. I want to be very picky, but we'll see what happens.
Yeah, that's very exciting. And you mentioned that you welcome people's ideas if they want to collaborate with you. So how can they send you messages?
Oh yeah. Okay. So you could just if you want to message through the podcast email, it's localmaxradio@gmail.com. I can give my personal email too. It's just my name, max.sklar@gmail.com. You could also go on my locals, which is if you're familiar with that site, it's sort of like a Patreon. So you do have to pay. It's like it's $4 a month, but we have lots of discussions on there about emerging technology, sometimes data science, whatever I'm discussing on the show. So it could be a philosophical thing or, that's kind of a fun discussion to have as well. But yeah, you could reach out to me. I think email is the best these days. I'm trying to stay off Twitter. I would have said Twitter in the past, but I'm trying to stay off a little more as it's just a bunch of voices that you don't want in your life. And, I don't think I need it.
Yeah. Yeah, that's good. Cool. I really enjoyed having this conversation with you, Max, and thanks for sharing your projects and the career journey with us.
Yeah, this is the longest podcast I've ever done. I feel like I'm ready to go on Rogan now. So
we're the Rogan for data scientists.
I have the stamina. Very good to know. Okay. Yeah, I appreciate it, Daliana. Thank you so much.